Welcome everybody to another courtesy public seminar series. My name is Dylan Rodrigo. For those of who haven't met me yet, I'm the new managing director for courtesy. As always, we have an audience here, and this is also live streaming via webcast. Today's topic is a little lengthy. IT and OT, information security architectural and operational divides in the energy sector. You've all seen the abstract, so I'm not going to actually go through that. To give the maximum amount of time to our presenter here, Mr. Mark Guth. Mark is the manager of corporate security, critical infrastructure protection compliance at NICO Gas, which is part of Southern Gas Company. Is that right, Mark?
Southern Company Gas, part of Southern Company, the big electric conglomerate.
Okay. So Southern Company Gas is a public utility with more than 5 million natural gas customers and over 6,000 employees. Mark has been here before, and Mark has over 30 years of IT operations experience, focused on telecommunications and networking. He has also 20 plus years of disaster recovery experience and more than 14 years of information security experience. Mark also supports the data loss prevention and e-discovery platforms for the company. And on top of all of that, Mark is also assisting the AGA, Natural Gas Security Committee, and Cybersecurity Strategy Task Force with improved security procurement language for control systems. Since this is live streaming, I'd appreciate if everyone, if they can, hold their questions until Mark's presentation is done, because we have live streaming and they are only able to ask questions at the end of the session. And then I'll switch back and forth and try to get that done. So with that, Mark, over to you.
Thank you. Appreciate the introduction. This is the first time I'm going to speak as a member of Southern Company, so I have to put out a little advertisement. Southern Company is America's premier energy company with 46,000 megawatts of generating capacity and 1,500 billion cubic feet of combined natural gas consumption and throughput volume, serving 9 million customers through its subsidiaries. Operations include nearly 200,000 miles of electric transmission and distribution lines and more than 80,000 miles of natural gas pipeline. So that's the company that I work for these days. So we're going to talk about the differences in security architecture, technologies, processes, and between the IT, information technology side of a business, and the OT, the SCADA side of a business. And really, what about those differences, either how it impacts cybersecurity resiliency. So here's the agenda, table of contents. We'll gloss through the IT and OT definitions pretty quick. We're going to talk about IT and OT security tools options. So, what goes on the workstations, what goes on the network, and how are they different between IT and OT? And then our favorite, cloud computing impacts. How is cloud deployed in an IT versus an OT environment? IT and OT system project management methodologies. What are the differences? Are there differences in those arenas? Maintenance and support. This will be one of my pieces that's near and dear to my heart. Training and certification opportunities. Other OT factors impacting cybersecurity that I didn't really feel I wanted to go into. Something like NERC-CIP. NERC-CIP, everybody knows about it, but I didn't want to do a deep dive in this particular presentation on that. Research opportunities, and then finally questions. And while I was I'm putting together the thought behind this presentation. When I was first asked to do it, I said, hey, I've got 15 years experience at least in IT and OT, and it's easy. I can tell you what the differences are, and I'll list them out, and we'll see how we act on those in the IT world, and then the differences in the OT world. And guess what? It's going to explain a whole lot of things, right? And as I did my research, as I walked through those processes, as I walked through those technologies, I found in a lot of cases my answers weren't what I expected. There's some that are fairly obvious, but there's others that I was very surprised in the end that there's really no difference in some of those sectors. So the bottom line is at the end is what is really different between those two sectors. I'm not going to spend a lot of time on this slide. It's just got the definitions of what is considered information technology, your payroll system, your timekeeping, what's considered operational technology, things, SCADA, and we shouldn't just think of SCADA being in the utility market. This Dasani bottle was filled by a SCADA machine. SCADA is manufacturing control as well. It's just in the energy sector, it's about pushing molecules of fuel, to some place. And Internet of Things, what constitutes the Internet of Things? And I'll have some interesting things, I think, to say about IoT in a SCADA environment here pretty soon. So this slide, it's tough to see, but the whole point of this slide is nothing more than this is the number of antivirus vendors in the information technology market as of September 2017. Doesn't matter who they are, where they are. The point is if you count up the dots, there's 20 of them. That's a lot of vendors in that market. Here's the OpSWAT. This is how many the percentage of market share that they have. And you got Symantec on the bottom, 4.7, McAfee 8.5. So again, this isn't to say, that any one of these vendors has this huge market share. But the interesting thing is when you go out and talk to the SCADA vendors, so I either went to their website or talked to these 9 vendors, and if you look, their primary AV partner is this here. And if you notice, between primary and secondary, there's only 2 choices for all practical purposes. There's McAfee and Symantec. That's it. And so if you go back to here, IT has 20 choices. SCADA has only 2. And for this GE, what does no vendor preference mean? Does that mean no vendor support? If I have a GE system and I call them up and say, hey, I'm having trouble, I don't think the numbers are right, are they going to ask me, do you have, McAfee installed on that machine? And if I say yes, will they say, call me back later, take it off, and then see how it's going? So, what are our options in that area? So, if you continue down the technology stack in an IT or an OT environment, Cisco dominates as a compatible switching infrastructure with providing support to all those SCADA vendors. Every one of those SCADA vendors will support them. One other vendor has their own hardened switching line, but every one of those 9 vendors I showed you on the SCADA slide supports Cisco. Intrusion detection systems. Everybody know what IDS is? IDS system looks at all the traffic and figures out if the people are supposed to be where they're going. Intrusion detection just alerts on it. It just says, hey, here's a transmission that I don't recognize. I just wanted you to know about it. IPS, that would block it. The intrusion protection system would say, hey, you're not getting through, here's an alert, I found this, I stopped it. But of all those 9 vendors, only 2 of them declared their support for a known product. So again, if you don't support my product and I got a problem and I call you up, are you going to say, hey, get rid of it and then talk to me? Log management. So log management is the accumulation of security and performance events associated with all the devices within that SCADA environment or that IT environment. And in the SCADA environment, nobody really cares. All the vendors said, I don't care who you use, as long as you're using syslog forwarding. So they're saying, as long as you don't configure anything on my machine other than to take that log file somewhere else, I don't care what product you're going to use. So, what are the implementation differences in these areas? So you'll notice in the OT environment, a lot of the security tools are passive. Antivirus just sits on the machines. It never scans the machines. Scanning in the OT perception puts too much usage on the disk and on the CPU, and therefore it doesn't have time to read the telemetry data that's supposed to be coming into that machine. So in most cases, OT engineers take and put the AV in just watch mode, meaning anything that comes into that machine gets observed. And it'll alert on something if it doesn't like what it sees, but it never physically scans the disk or the CPU. The same thing for IDS. In general, OT is configured to choose not to prevent any SCADA system connection, any remote device connecting to the SCADA system, but rather in IDS mode to say, hey, I recognize something isn't necessarily right. I don't know who it is, but go ahead and take the data. The usual point of SCADA systems is to take and receive that telemetry data and then do something with it. Operational technology on the OT side of things, signatures for the antivirus, for the IDS, and the operating systems, your Windows or your Unix, must come through an intermediary. The whole theory of OT systems, of SCADA systems, is that they're air-gapped. They're supposed to not touch anything, especially anything else that touches the internet. But where do you think AV signatures come from? From Symantec. And Symantec puts them on the internet and then drives them down. The same thing with Microsoft for operating system patches. So those must come through some type of intermediary that's specially hardened, that has a special business and technical process to reach out to somewhere in the corporate network, grab those, and then be able to deploy those within the OT network. And that's a challenge. And finally, our Internet of Things on the OT network. So if you read the direction or the definition of Internet of Things, they mention things like, a refrigerator talking to something that talks to your thermostat. They've got your Fitbit that talks to your Peloton. That talks to the Wi-Fi network in the office, that talks to, the PeopleSoft HR system to update your wellness dollars and things like that. That does not exist. That does not exist in the operational technology arena. Every piece of equipment, anything that's connected to the SCADA network has a specific purpose. You don't have any freeloaders. There's nothing, if an IT person says, hey, it'd be great, to put the time card machine on your SCADA network because we don't have a network out there, or the door, the access card swipe, the OT person better say, no way. That's not important to the operation of the internal workings for a SCADA system. So IoT doesn't really exist to the same degree that it does in IT systems. In the OT environment, operating system and application patches go through very rigorous testing procedures. And they're delivered through an intermediary we talked about before. But in our company, it may take 6 months for an application patch to get deployed to a SCADA system. That's probably about average. Maybe your big payroll systems are like that, but in general, you would find application patches that are, especially ones that are exposing critical vulnerabilities, would be deployed a lot faster than that. And finally, whoops, that's not what we wanted to do. We wanted to say, in the OT world, there's a lot of old devices that are connected to those OT networks. And those old devices have older ICS protocols, Modbus, things of that nature that they talk. We're getting there. We're getting more and more, standardization around Ethernet and the IT type protocols, but those devices have a very long lifespan, and so they're not, there's things on our SCADA network that have been out there for 40 years and are still there. So how do we, my premises here, and these could be, you could call them perceptions, premise, perception, same thing. How does the differences in those two markets, IT and OT market, contribute to impact cybersecurity resiliency in this industry? And the smaller supply of OT security technologies, the smaller number of AV vendors, the smaller number of IDS vendors, how does that contribute to differences? And if you think about it, there's got to be an economy of scale that exists in a company, especially the size of, let's say, we've got 38,000 employees. And to have one AV vendor, to me, seems like it makes, it would be a prudent thing. Logic says less is more, but that's not what the case is in the OT environment. You only have those two vendors that are supported. So my conclusion on this is, logically it says it should be better, but really in reality, is it? The more passive implementation of OT security technologies contributes to the difference in IT and OT operations. So the difference in these two is that in the OT environment, you have a lot more stringent controls on the perimeter. Things like remote access, that's frowned upon. Whereas in the IT world, I can get to enter my time and look at my check from home without two-factor authentication. So in the IT world, it's embraced, whereas in the OT world, it's not. You have other things around, like the passive nature of the IDS, the passive nature of the AV. And so while they have identical security posture concepts between IT and OT, the difference is that in the OT world, you're substituting the risk for the data acquisition. Again, The whole goal, in the most part of SCADA, is to get that information to the control center, so the control center knows what that device is, those devices are up to. And the architectural differences between IT and OT contribute to the differences. You know, again, it's really the same. It's really the same conclusion, and that is, you know, if you have the right perimeter controls for a SCADA system, then you can forego those endpoint controls, and don't have to delve into as deep on the endpoint side of things, like scanning the disk, blocking and tackling all unknown assailants. So let's talk about cloud. So what is considered cloud? Everybody knows there's infrastructure as a service, platform as a service, there's software as a service. I probably should have had a quick definition slide for this. You know, there's public cloud, private cloud, hybrid cloud. And so one of the challenges we have in the utility industry is just understanding, having the same conception of what cloud is between what the vendors say it is and what the different utilities say it is and what the regulators say it is. Complexity of cloud implementations, including data accessibility, access control, and security practices. Anybody who's dealing with the GDPR knows that German folks can't have, if I have one German customer that's a utility customer, and he lives in Germany, that person lives in Germany, I have to protect his data in a whole mess of ways that I don't have to protect the United States people from. So if that service is in a cloud, how do I know where that data is? That data could be in France, it could be in, you know, Vietnam, it could be here in the States. So, you know, where's my data? Who has access to data? You know, we've seen AWS had a big outage where a router technician, you know, put in the wrong input string for an iOS upgrade, and the whole East Coast for AWS was down. Another one had the wrong configuration on a server, and a bunch of people could see other companies' data. So, you know, there's complex configurations associated with that. It's scary, but cloud services may already be in use by your SCADA vendor. So remember that the list of 9 SCADA vendors on slide 6? Every one of them offered cloud services, either to deliver their product, deliver their service, or provide you SCADA in the cloud. So, you know, how do I know as a company if my support organizations are already putting my data in the cloud without my knowledge? And one of my favorite is the fact that regulatory agencies are embracing cloud services to help lower ratepayer costs. I get calls from the Illinois Commerce Commission that says, hey, talk to me about cloud. I want you to implement cloud because I want you to get the lower costs sent back to the customers. And we all know that there's what is considered cloud, what's the total cost of ownership? The last one, what are the pros and cons of those cloud offerings? And how do we get to that? How do we get to that information so that we can make the right decision associated with these types of service offerings and deployments? And so, do cloud implementations in IT and OT environments impact cybersecurity resiliency? Obviously, you know, it is the complexity absolutely does. And utilities must have a clear understanding of you know, cloud vendor security controls, how they impact the cloud vendor, where our controls can be put and superimposed on top of the vendor's controls, where they overlap, where they begin, where they end, and what the impacts of that kind of data stored in the cloud is. If it's benign data like, like purchase date or something like that, I'm trying to think something in the utility space. We have energy efficiency data that's put up in the cloud, and that's service calls that have been gone to help reduce consumption. So there's no customer information, no address, nothing like that. But that's okay to be in the cloud. But if I was going to put my credit card processing transactions up in the cloud, there'd be a whole different question associated with that. Security question. Premise 2, SCADA is not to be meant to reside in the cloud. It's already there. The challenge is I may, as a company, may not know it. It may not be, the primary product that they're providing me. It may be a support wing of that product, but some part of the product, either in the supply chain side of it, where it's being, designed, developed, and tested, or where it's being delivered to me, is already in the cloud. Waterworld states that cloud services can save small water companies and municipalities as much as 90%. Why are they not going to use it? I mean, there's just no way that it's going to stop it. Cloud will become even more complex in the future. I totally believe this, and that's because technical innovations will continue to drive companies to deploy cloud information. Nicor Gas has just done started a AMI project, automated metering infrastructure for 2.1 million natural gas homes and businesses. Well, if it's going to collect the data point from these devices every 15 minutes, let's just say there's 2 million of them. That's about 100 data points a day. That's 200 million data points in a day. Do you think my rack of IBM 360s can process that? No way. If you really want to get into what is that big data going to do and show for us, you're most likely going to drive towards some type of cloud solution. And then the funnest part of that is regulatory changes will make cloud even more important. So what is this Public Utility Commission in Illinois going to push for? What are our state organizations going to push for? How are we going to have to regulate or govern that data as we get more detailed, like data protection acts? Today, it's Social Security number and your name and your birthday in combination with some kind of logon or password. And tomorrow, they're talking in some states that my electricity usage is going to be considered PII. So if I'm an electric company and I'm already putting that up in the cloud, I have significant angst associated with the potential of that changing. So project management methodology differences between IT and OT environments. So project management for IT is typically based on, it's PMBOK, and with a PMO, a project management office project manager, formal project management methodologies. In the past, at our company, OT projects were run by a SCADA engineer who had a spreadsheet of the timeline and a test bed to test things. It didn't have the same rigor. But I will say that's very good, or is getting better, is the fact that procurement processes now include cybersecurity provisions. So you see this a lot from legal perspective and strategic sourcing. Those departments are reaching out to information security and asking, give me some boilerplate language I can put in IT contracts, in services contracts. American Gas Association has a cybersecurity language for energy delivery systems tool that was built. I built it. And it's off of the IETF cybersecurity tool, not tool, but in energy delivery systems paper from 2015. So you're seeing a lot more contributions and considerations for cybersecurity in the procurement process, the vetting of vendors, and then the actual delivery of product. One of the challenges we have is that SCADA vendors are often long-term incumbents with established relationships with the OT staff. Therefore, you get a lot of trust that's built up between those organizations, between those individuals, and in some cases, that trust takes the place of security or of controls. And so it's a challenge to ensure that both parties are being objective about what the product can deliver, what the control structure can be, as well as what the product is actually delivering and what it should be delivering. IT application testing focuses on very defined test cases, documented test management, precise tracking, quality assurance checks, and whereas OT focuses on delivering identical results. We'll have a test system sitting next to a production system, and both of them should have the same numbers for the same reading. If we're deploying technology that's going to give us some automation of an existing OT business process, people will calculate that stuff by hand for months and compare it to the value on the screen for the new system. So that parallel testing happens for a lot longer in the OT environment than it does in the IT environment. And then finally, in production, it's not uncommon we actually are putting our main SCADA system in parallel in 2 weeks for about 6 months. So we've upgraded it, and both will be in place for approximately 6 months. You would never see that with, an HR system or a, customer relationship management package in the IT environment. So what I found, though, was when I went out and looked at project management was that my first premise was they're different. And as it turns out, when I went and talked to the SCADA vendors and I talked to peers within American Gas Association, what I found is they all offer as services commonly accepted project management methodologies. They'll have PMBOK certified project managers, PMP certified project managers that we can hire to help run our project, our SCADA implementation project. And talking to our internal folks that's kind of the way they like to go. They don't typically use internal PMO. They still don't want to use the IT. They're related to IT, and we don't want to use them, but we will use a third party that the employs the same kind of project management methodology that they do. IT and OT applications wind up having the same, in general, have the same test period length. So again, informally speaking to AGA members and my peers at Southern Company, it's all between 3 and 9 months based on the system criticality. So there, again, when you actually look at it, there's not much difference between the two. And then the only difference that I did find is that OT systems definitely get paralleled longer than IT systems. Again, the practicality of standing up 2 payroll systems is very, very, very small, whereas it is not uncommon for OT applications to sit production and new production to sit side by side for 6 months or more. So what are the differences in IT versus OT maintenance? The complexity on the OT side for that OT endpoint is so much different than it is on the IT side. The device on the end of an OT network could be, it's a machine. It could be a valve, a motor, an engine, a compressor, a fan. It's not, in a lot of cases, it doesn't have to be computer-based. So the challenge is different there. The life cycle of OT endpoints could be decades. Most of your IT equipment is what? 5 years, some 7 to 9. But OT devices, there's pieces of machinery in the Nicor gas network that are 40 years old and still there. And so that's quite a bit different on how those devices are serviced. Remoteness of devices, individual devices located remote areas, weather extremes. Our company has 20,000 miles of territory, that pipeline in our territory, and we have 10,000 set points. You do the math, that's 1 for every 2 square miles. And obviously there's concentration of those in big cities like Naperville and what have you. That means there's places where, it is 50, 60 miles before you get to that remote device. And we'll talk about what does that mean later. In the OT world, remote access to SCADA applications is very controlled. In the IT environment, remote access is common. We've talked about that before with time entry, benefits, et cetera. However, in IT and OT, the primary support for endpoint devices often involves a third-party organization needing remote access. I've got a big, huge compressor in our storage field in central Illinois. Very expensive piece of equipment. We did all of the contract negotiations, everything looked good, all the cyber about it was fine, and 6 months after it got installed, I get an email from the manager of the field, and he says, hey, could you look at this real quick? It's the maintenance agreement. And I said, okay, sure. And the maintenance agreement has an RTU on it, and that RTU has a cellular connection that they can get to. It goes to the internet, and they are able to monitor this. They're going to monitor it 24/7, 365 days a week. And I was like, this is nuts. This is, we've negotiated this for 18 months. Nobody ever said this was going to come up. And they said, oh, it's a service they've just started offering, and great. So now we either don't maintain this equipment because we don't have the expertise to do it, or we give a third party access to the left side of an RTU for one of the most expensive pieces in our entire most expensive asset in our entire company. And the question is what else is on their network and what else can they get to our network? So that's probably the biggest challenge that we have. How did Target get hacked? Does anybody remember? HVAC company coming in and being able to move laterally. Well, it's somebody who hijacked their credentials and moved laterally across the Target network until they got to the point of sale systems. So, does maintenance and support differences support issues with cybersecurity in the energy industry? And there's a different technical skill set that's needed for supporting SCADA endpoints. While the network technician probably can learn the RTU functionality and protocols, the likelihood of them understanding how that machine works on the end of that is pretty slim. So, and that's not a mainstream skill either. So you'll have these technologies that are supported by a third party, somebody coming on site, plugging in a laptop possibly into the network or into the device and trying to resurrect that device. They also use those older SCADA protocols, that I talked about. Good news is as that stuff gets replaced and there's a big modernization movement going on with all utilities, those old deprecated protocols go away and the new protocols go in place. So these points being all over the place, your IT network is fairly flat. It's usually office or service company based, whereas the OT network is not. It's usually pipeline or transmission line or device in the field based. And therefore, you need that remote access to those SCADA endpoints for support purposes. And as I indicated before, that's always going to be a challenge in the SCADA arena. It's a necessary cyber risk to ensure the safe operations of these systems. But it is probably, I would say, the biggest challenge that exists in the industry today. And it shows up here too, these third-party support organizations that the business is signing with need remote access to those devices in order to properly maintain them. So security training in computing environments, let's go through this pretty quick. If you look at SANS, in 2015, this is the newest info I could find on a CISSP or ISA 99 training. These three are considered SCADA-related type ICS system training certifications, and these are considered IT. And you'll just notice, other than the short gap here, there's a big difference here. So, how do we get SCADA technicians, OT involved individuals to take the right courses? And I don't have an answer to that. I'm just posing that question. And then if you look, ISACA predicts a global shortage of, actually that should be 200,000, not 2 million, but 200,000 cybersecurity professionals by 2019. It's about 40,000 a year. How do we get people to, come to this industry to work? Okay, so we do agree that, that more training is needed. Technicians need to take a security first focus. How do I make that connection securely, as opposed to just how do I make that connection? Companies will face increasing challenges of filling cybersecurity positions. So will the industry. We'll just talk to these together. Somehow we've got to figure out how do we devise strategies to attract, I wouldn't even say skilled cybersecurity candidates, but candidates with a computing aptitude, especially females and minorities. How do we attract them to the industry, and then how do businesses keep those high-performing employees in those positions? This is a great job. I love it. It's a lot of fun. It pays well. It's exciting. You won't find a job that changes as fast as a cybersecurity professional job does. Every month there's something new. But how do we get people to apply for those open positions? Okay, we're just going to quickly go through these. Other differences. I didn't really look at NERC-CIP in the sense that it governs only the bulk electric system, and it's prescriptive. It's not very often that an energy company will say, hey, I will put those onerous controls on the rest of my assets. They usually don't. So we kind of left them off. Disaster recovery, I kind of ignored that in the sense that you think about it, a transformer, a critical transformer or a critical compressor, it's really location dependent. It's dependent on where that voltage drop you're trying to correct is, or where that pressure drop that I'm trying to correct is. So if I have a primary compressor there, I can't put another one 40 miles away. I've got to put it kind of in the same geographic location. In the IT world, if my mainframe is in Chicago and my backup's in Dallas, it doesn't matter as long as they're not next to each other. As long as there's a difference in distance, we're okay. It will matter, in the IT world. It does matter when, hey, all the kiosks at Atlanta Airport were down when they had the power outage. Could anybody in Atlanta get to get a flight? No, because they couldn't even log into the kiosk. So, it can matter in the IT world. It's just not the same as in the OT world. Budgets. Most local distribution companies are allowed a fixed rate of return, and their budgets are determined during rate filings. New rate cases may not be filed for years, maybe a decade. So trying to replace a $6 million SCADA network without a rate case is most likely not going to happen. So, it's expensive technologies take a rate case in order to, continue on with them. And then the market, is just changing as we've got in Illinois, we've got energy efficiency where your bill, maybe not your personally, but all the utility bills have a surcharge for the utility to come back and teach you how to use less of that energy. And so utilities are going to face a lower and lower market demand going forward. Prices are lowering. You're getting renewables and lower emissions coming as well. So where do I think the opportunities, research opportunities exist? The Cloud Security Alliance, CSA, is a great organization. What we need to do is to press them for an OT operational technology domain. They have 34 CSA domains. Is operational technology one of them? No. So there's an opportunity for us. American Gas Association, Edison Electric Institute. I'm guilty. I'm part of that group. And there needs to be a cloud-focused subcommittee within that group, and I'm going to press for it at the end of this month. Cloud offerings. We need to get the pros and cons, developed and researched in the OT environment. We've got them out there in the IT environment. We don't have them in the OT environment. OT vendors, can we get, can we find a neutral party? Can we fund a neutral party that would be responsible for, requiring SCADA software, RTUs, and PLCs to be, like Underwriters Laboratory, UL approved, OT approved. So at least there's a baseline of security considerations that have already been taken care of. I don't want to have to reinvent the wheel every time I start dealing with, a new SCADA vendor. New technologies, we got PACs coming. They're out there today, programmable automation controllers. These are nothing but computers. The old RTUs and PLCs were very limited, in what they could do. They only had so much programming power. These things can pretty much do anything. And when you can do anything, you can also have, cybersecurity challenges associated with them. Cloud providers. Hey, they have PCI certified vendor ship in that. PCI is payment card industry. It's how credit card management, credit card governance. And why can't we get cloud providers to be somehow OT certified? And finally, again, I'm going to harp on this. How do we attract female and minority candidates to fill cybersecurity job openings? There's no way that we're going to get better at closing the cybersecurity challenge by having 40,000 open jobs every year. There's no way. So we need to figure out, I was talking to Tim earlier, and he's got some very interesting stories on informal surveys he's done with people in that space. And we need to figure out how to overcome some of those perceptions, by that workforce, and be able to attract them not just to the industry, but attract them to the individual companies. So the companies have a responsibility here too. So, are there any questions? I know there will be. Yes.
Has there been any thought?
Oh.
Has there been any thought to the security and operational risk of relying on predominantly a single operating system vendor, namely Microsoft Windows, and pushing the SCADA vendors to implement solutions based on Linux and other open source technologies?
They all support other open source technologies. It's the challenge, I think, more so is on the utility side of things, and whether or not the OT individuals are willing to, the OT departments are willing to do that. We have some Linux in our environment. It's not as universal as it is on IT, not by any stretch of the imagination. Hopefully, from the vendor side of things, some of these devices will come out with Linux instances, because they certainly are easier to harden, as well as easier to keep secure from a patching perspective than, let's say, Windows 10 is. Yeah.
So you've given us quite a few examples of issues that separate the IT and OT environments, and they do have quite different things they're trying to accomplish. But I wasn't so sure from the presentation whether you think that the differences are mostly accidental or whether they're intrinsic, and whether one of them is better than the other in terms of its current capabilities. Like, should there be convergence, or would you expect greater divergence of the two?
I would, and that's what I struggled with at the end. That's a great point. I would expect, I said it in the beginning, less is more. I would expect that if they were able to support the same set of, tools and the same set of equipment, basically, a network guy doesn't work on the mainframe. The OT network guy doesn't work on the compressor. So I understand that there's differences there, but I would expect in the long run that if we had a more homogeneous, structure, architecture, and business processes, that you could move, we'd be better off. You could move people from IT projects to OT projects and vice versa, and hopefully get some cross-training in that will give you the ability to, supplement that workforce that I'm struggling to find in general. I think it's the right way to go. I'm not sure, based on some of these things that I pointed out, whether or not there's, what's the word I would want to use? Intrinsic impediments to doing that. And frankly, if we remember, a lot of those OT folks have been there forever. And so there's the IT side of things, they're much younger. And so there's, is there naturally some resistance? I guarantee you there is. How do we get over that resistance?
Amy, I think there's a question online. Would you mind?
There's not a question online, but maybe you want to let the online audience know that they can ask questions via WebEx.
So the folks online, this is open for you now. If you have any questions, please go ahead.
I see one.
But since then, yeah, go ahead, please.
So I was wondering, there's NERC SIP for electricity. What is the equivalent for gas? Is there an equivalent for gas?
Nothing.
Nothing?
Yeah, there's
Okay.
nothing. Gas, there's a concerted effort by regulators, especially on Capitol Hill, to enforce more NERC, I'm going to call it NERC SIP light, because it's, they realize the hammer doesn't need to come down, but they have been working with American Gas Association for years to develop, guidelines, the critical infrastructure framework and other guides that help govern or direct gas utilities how to, implement security, cybersecurity, and physical security, and then how to operate it effectively. So far there's been a uneasy quid pro quo, or an uneasy, homeostasis state that we've come to, and I think we're only one major utility screw up from, the hammer coming down, to be honest with you. It always, anytime there's a major issue, an explosion or something, that you hear them on Capitol Hill and it starts to ramp up, and then they find out, no, it would have happened no matter what. It was, was a train derailment or something. It goes back to this uneasy calm there.
We'll go to the internet and then we'll go there.
Okay, what role does the security vendor play in the IT/OT convergence, and what expectations should the consumers be placing on the security vendors?
So the vendors have a big role, and what I'm kind of disappointed in is the fact that the vendors haven't played a more aggressive role in demonstrating how their products and services can help, make the whole environment, the whole OT, and even the IT as well, environment even more secure than it is today. It's usually a vendor flaw that causes the vulnerability that gets exploited by somebody who figures it out, that then impacts, either all of us or, what happened with Equifax. They didn't patch a server for 2 months, as a vendor flaw, WordPress or something, and boom, 6 million people's data is exposed. So I'm disappointed in SCADA vendors. My SCADA vendors that I deal with should be more aggressive. They know what I want, and yet I always have to go pull it, from them. why they aren't partnering with, the Ciscos of the world or Aruba or, other PLC vendors or what have you to put a test bed. You guys have a wonderful lab over here. It's fantastic. It probably is worth more than, the northern half of Illinois gas network that I've got in place. But, it really is incumbent upon them to drive it forward. Hopefully in the future, we'll be able to look at those vendors and say, hey, I know you've been working with us for 30 years. Your product set doesn't fit what we need anymore. How do we move to a product set that we can deploy?
At the back there, go ahead.
So with all these cloud offerings and stuff, it looks like the air gap is pretty much barely
Gone.
there, right? So, but a lot of decisions that get made, like 6-month patching cycles, are based on the fact that we have a strong air gap out there. So do you think those decisions are going to change as the air gap becomes non-existent?
I would say, yeah, I think it has to. I think the air gap, even without cloud, I think the air gap is much smaller than the perception, internally is. And that is because, hey, look, we put a new RTU out there or we've got a new mandate to understand consumption in the Joliet, Illinois area. Well, guess what? Now you're taking SCADA data and you're putting it outside into the IT network somehow. And the whole premise of being air gap is to have no doors. And more of that data, is winding in the IT world, and it had to get there somewhere. And even if you have the best firewall, in place, and you write really good rules, you have to go back and look at those rules. I don't know what's too often, weekly, but monthly, to say, hey, did the rule change? Did somehow, something is different, and now guess what? There's a way to go this way, But if you think about it, you're absolutely right. The cloud is bringing the internet closer to the OT network, and that's a huge challenge. If we're just sending stuff out to the cloud to be processed, that's one thing. If it's accumulating that data from RTUs and PLCs, boy, we got a problem there.
Unfortunately, we are out of time. If there are any other questions, Mark, is it okay if folks can email you with that?
They can.
You've got the email address there.
mguth@southernco.com.
Right. So just to wrap this out, archive of this seminar would be made available within about a week or so on our website. That's cred-c.org. So join us on April 3rd for our next Credit seminar by Jianhui Wang from Argonne. And let's actually thank Mark for a wonderful presentation.